the European Space Agency released the first 5 pictures from the Euclid Space Telescope that's orbiting in the same Lagrange point as JWST. The Euclid telescope is designed to capture images of a large number of galaxies within a cluster. Now, this first batch of 5 photos is similar to what is normally released for any new telescope. Some of them are images of well-known astronomical objects that are chosen based on how impressive they look, and other images are selected to show off the capabilities of the new telescope. So I decided to choose the image that is arguably the most boring, but is actually the most representative of what the telescope's primary mission is. In order to understand the Euclid telescope's primary mission, we must first review what we had learned from the Sloan Digital Sky Survey in 2007 and from the Hubble Space Telescope in 2009. This map that I'm showing now was created using data from the Sloan Digital Sky Survey. The Sloan Digital Sky Survey was created using 2 relatively small 2.5-meter wide-angle telescopes, but with 120 megapixel cameras and 2 spectrographs that can collect the spectra from over 600 galaxies in a single night. One of these telescopes is in New Mexico and the other in Chile. Building telescopes in the deserts not only means fewer clouds, but also less humidity to distort the images. What you're seeing on the screen now is the Able 307 galactic cluster. Galactic clusters are very massive, so they contain good examples of gravitationally lensed galaxies that are far behind them. The light from the background galaxy gets bent around the cluster and appears warped or multiple times. The smear of stars going from the left to the right in the image now is light from the same stars as the galaxy on the left, but some of the light has been bent around the cluster to get to us. Explaining these shapes and positions can only be done if there is more mass in the galactic cluster than can be accounted for by totaling up all the visible mass in the galactic cluster. Now here's the boring image from Euclid. There are over 50,000 galaxies in this image. Almost every point of light, other than the very bright ones, are galaxies. Since the data from Euclid also contains the spectra for many of these galaxies, the distances to each of these can be calculated, and with this information, we can create a 3D map of these galaxies. Because Euclid had to be launched into space, it uses a primary mirror that's only half the size, 1.2 meters, but has one instrument with 36 16-megapixel cameras for a total of around 576 megapixels, and another instrument that has 16 4-megapixel cameras. And the light that is sent to these cameras is split into one of 3 infrared bands before reaching the detectors, so it collects a rough spectrum of every pixel in the image. Infrared detectors need to be kept really cold, so that's why Euclid is located in deep space close to JWST. To study the individual distortions of the galaxies by dark matter, we need to observe at least 1.5 billion galaxies. Mapping the distribution of dark matter throughout the universe gives us important clues about what dark matter might be made of. Different theories of dark matter predict various clumpiness or fluffiness of dark matter based on how it interacts with itself and normal matter through gravity. By the way, I looked it up, and according to Oxford English Dictionary, the word clumpy came into use around 1820. However, neither that nor the Webster's Dictionary lists clumpiness as a word. But Wiktionary does list it, and it's commonly used in astronomy literature. Clearly, the dictionary community has some work to do. On the other hand, fluffiness is definitely a word according to my research. There are links in the description for where to find all these images and more.